In the last lecture, in monosaccharide topic, we completed three types of sugar: triose, tetrose and pentose. Now next, there is hexose. Here we take value n is equal to 6. So empirical formula of any hexose sugar, that is C6H12O6. Now hexose sugar divided into two, some having a aldehyde group, so that is aldohexose, and some having a ketone group, so that is can say ketohexose. First we prepare the structure for aldohexose. Aldehyde group always present at the first carbon and ketone group at the second carbon. First carbon, second, third, fourth, fifth and sixth. First carbon, second, third, fourth, fifth and sixth. Any category of hexose sugar, their third carbon, oxygen present left side. Oxygen present left side. 7 carbon containing N is equal to 7 if we take, so we can getting the heptose. Empirical formula of heptose, that is C7H14O7. This heptose having just one example, there is ketoheptose, and they having also at the third carbon oxygen present at the left side. First carbon, second, third, fourth, fifth, sixth and seventh. And that is having a ketone group. Now aldohexose we are preparing. So already one hydrogen and 2 oxygen arranged. Now first we are arranging the oxygen. Three oxygen arranged, 4, 5th and 6th. Now hydrogen. Already one hydrogen arranged, 11 left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. This is the biochemical structure of glucose. Glucose is the example of aldohexose type of sugar. Now we are drawing here ketohexose. 2 oxygen already arranged. Now left to arrange rest of the 4. 1, 2, 3, 4, 5 and 6. Now arrange hydrogen. First, second, third, fourth, fifth, sixth, 7, 8, 9, 10, 11 and 12 hydrogen arranged. This is the biochemical structure of fructose. Fructose is the example of ketohexose. Now glucose having their isomer, this isomer as a form of epimer. It means changing of H and OH position at the second carbon, third carbon, fourth carbon, fifth carbon. Here in a structure of glucose we change the position of H and OH at second carbon as well as the fourth carbon and obtain the epimer of glucose. Now these three chemical structure same or different? All three chemical structures same. All three chemical, that is glucose. Now we are doing changing inside the glucose. Second carbon, change the position of H and OH. So this is the epimer of glucose and that is mannose. Change the position at the fourth carbon of glucose. Position of H and OH change. Add the glucose at fourth carbon. So getting new chemical, and that is galactose. So galactose, mannose and glucose, they are epimer. Now, what is the significance of all hexose type of sugar? So, common significance of all hexose sugar, they are used in procedure respiration, especially glucose. On glucose, respiration occur and we get the ATP. That's why this hexose sugar is the source of energy. Is the source of energy for body. The individual characteristic, glucose present high amount inside the many structure. For example, they are present inside grapes. That's why it's cancer grape sugar. Glucose present within our blood. That's why it's cancer blood sugar. So another identity of glucose, that is considering blood sugar. Grape sugar, because that is present inside the grape. Mannose, many molecule of mannose. Mannose is monosaccharide gather and producing mannan, which is present inside cell wall of algae. So that is present inside the galactose, which is not present in free form. Galactose react with the glucose and producing lactose. Lactose necessary for the sweetness of milk, means milk sugar, that is lactose. Lactose made up of glucose plus galactose, so that is disaccharide. Galactose also present inside the structure of pectin as well as hemicellulose, means in a nature galactose not present in free form, they are associated with the other components. Our nervous system tissue, which is also made up of a component having a galactose. So galactose is considering with sugar, brain sugar. Fructose, which is highly sweetest carbohydrate. This is sweetest carbohydrate. Fructose present inside the juice of fruit. Fruit juice containing the sugar, that is fructose. That's why fructose is cancer. Fruit sugar. And the other identity, most sweetest sugar of most sweetest carbohydrate, that is fructose. Now we completed here hexose. Next one, that is heptose. Heptose only one form available, and that is the ketose form. Keto, heptose. Empirical formula C7H14O7. Here we take N is equal to 7. CH2OH H OH 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 CH2OH H, 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 H. 7 carbon, 7 oxygen, 1, 2, 3, 4, 5, 6, 7. Hydrogen, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This is pseudoheptulose. This chemical is pseudoheptulose. Pseudoheptulose is the example of ketoheptose. 7 carbon containing longest monosaccharide, which is pseudoheptulose. Pseudoheptulose were having a role. So pseudoheptulose having a role in dark phase of photosynthesis. Dark phase of photosynthesis. Actually, many chemicals participate in this longer process, that is dark phase. One of that is pseudoheptulose. 7C, 7 carbon containing. Now, Here we complete all monosaccharides. All monosaccharide we are drawing here in a single row. It means this is linear structure of a monosaccharide. Now monosaccharide joint in producing disaccharide and polysaccharide. For the production of disaccharide and polysaccharide, linear structure not to participate. They need ring structure. So first, before learning of disaccharide and polysaccharide, we have to learn how this linear structure which is converted into ring structure. Especially di and polysaccharide which is made up of hexose sugar such as glucose, galactose, fructose. So first we are going for the learning of glucose, galactose and fructose, how their ring structure converted into, how their linear structure converted into ring structure. Most of the chemical in nature having their two images, their right-handed structure as well as the left-handed structure. We draw here glucose in the right-handed and the left-handed structure. What is the difference between right and left-handed? Though we mention H and OH position at right side, if we mention in a left and left side mention into right, 180-degree rotation, so we get the two chemical. Right-handed mention that is D-glucose and left-handed mention that is L-glucose. D means dextrorotatory structure, L means levorotatory structure. So most of the chemical in nature in their two form, right-handed form and left-handed form, means mirror image structure. Now given chemical which is dextrorotatory or levorotatory, how we can understood? So if we have to check dextrorotatory or levorotatory, so first we prepare the solution and add inside test tube. For example, we make here the one test tube with having a glucose solution and second having a fructose solution. And then we pass in both the solution plain polarized light. It means the light whose rays only in one direction. If at presently we pass plain polarized light in a glucose solution and this light bent toward which direction, that we can measure with the help of polarimeter. Polarimeter indicate after passing light from the glucose solution, light bent towards the right side means clockwise direction. So this solution having whatever chemical that is dextrorotatory, means dextrorotatory solution bend the light towards the clockwise right side. Now second solution that is fructose solution, there were pass plain polarized light. After passing of plain polarized light, polarimeter detect that this light bend anti-clockwise means left side direction. So given solution having whatever chemical that is levorotatory, levorotatory can say levulose and dextrorotatory can say dextrose. So glucose in dextrose in given solution as well as the fructose in which nature? Levulose in form means L form. So two types of structure, mirror image structure, dextrorotatory and levorotatory. Dextrorotatory bends the light towards right direction, this is left direction. Now this is linear structure of glucose, this is D-glucose and this is L-glucose. Our syllabus most often use that is D-glucose, dextrorotatory glucose. Now we are going for the learning of how linear structure which is modified into ring structure. This is original D-glucose. Now we are doing here changes to conversion of linear into ring one. Ring always form between though place carbon double bond oxygen present, that carbon as well as the last second carbon. So here carbon number first joined to carbon number fifth. Rules and regulation for preparation of ring by joining of which carbon? So though carbon having a C double bond O, that carbon as well as the last second carbon joined to each other. Now hydrogen from fifth carbon, that is shift at the first carbon with oxygen. So one bond open. Here one valency of carbon missing and here one valency of oxygen missing. So this oxygen joined first carbon to fifth carbon. So this is the ring completed. In this ring, high carbon present within the ring along with oxygen as well as 6 carbon out of the ring. Now, in a ring structure, we have to prepare the 6 corner, 1 corner for the oxygen and 5 corner for the carbon. This oxygen joined first carbon to fifth carbon. So first carbon here, second here, third here and fourth here, fifth and 6 outside. Every corner representing carbon. Every corner representing carbon. If instead of carbon, if we have to write specific atom, so we have to mention here, for example, oxygen, so we have to mention here. Now we mention what is present at the first carbon. So first carbon present H as well as the OH. What is present at the second carbon? H, OH. Third carbon OH, H. Fourth carbon H, OH. Fifth carbon H present. But 6 carbon outside the ring. 6 carbon present outside the ring. So we are mentioning outside the ring. CH2OH. That is the carbon number 6. So this is the ring structure of glucose. Ring structure of glucose also two form. At the first carbon H upper side and OH downside. The reverse also. At the first carbon OH upper side and H downside. Rest of the structure remain as it is. This is carbon number first, second, third, fourth, fifth and the sixth. So here this is D-glucose. This is also D-glucose. Both the glucose in which form? Ring form. Just difference in their first position. We mentioned previously with respect to isomer. H and OH position, just observe difference at the first carbon. So two chemicals they are enomer to each other. So both these are the enomer of glucose. This is can say alpha D glucose. So this is can say beta D glucose. Alpha and beta D glucose both they are enomer to each other because at the first carbon change the position of H and OH. Now question is that why we here learn alpha D glucose as well as the beta D glucose? Because our future di and polysaccharide, some di and polysaccharide made them of alpha D glucose, whereas rest of beta D glucose. That's why we have to learn previously here. Only changes at the first position, H and OH just rotate. So now we complete here the glucose ring structure, how to prepare. Then we can mention about other. Suppose galactose, D-galactose. How to prepare the structure? So I am carry out changes here. You have to draw second structure entire. What is the difference between glucose and galactose? So at just fourth carbon OH and H. This is what? D-galactose. So this is D-galactose in a which form? Ring form. Just changes at the fourth carbon. H and OH position change. So now this is the two chemical. This is alpha D-galactose. So this is beta D-galactose. This is alpha D-galactose. So this is beta D-galactose. So now we are having a 4-ring structure, alpha and beta D glucose. Now alpha and beta D galactose. You have to draw this structure by second time. I just change this directly from board. Now next structure we will write, that is fructose. Fructose linear structure, and how does convert it into the ring structure. Now we mention here dextrorotatory fructose structure. Once again drawing here same structure of fructose. This is original. Here we are carry out modification to conversion of linear into ring. Ring always form between the carbon having a double bond oxygen and last second carbon. This is first carbon, second, third, fourth, fifth and sixth. So here ring form between second and fifth carbon, OH from H, H from OH at the fifth carbon, separate and attach to oxygen of second carbon. One valency open. Now here one valency of carbon missing and here one valency of oxygen missing. So this oxygen joins second carbon to fifth carbon and ring completed. With respect to this ring, we can understood that this is the 4 carbon present within the ring, inside the ring, and first and sixth that is outside. So we have to draw pentagonal ring structure. Pentagonal ring structure, this is every corner representing carbon and one oxygen. This is second carbon, third carbon, fourth carbon, fifth carbon. See here, second and fifth joint with the oxygen, second and fifth joint with the oxygen. Okay, now write the position of H and OH. First carbon outside the ring, CH2OH as well as OH. Third carbon, what is present? OH, H. Fourth carbon, what is present? H, OH. Fifth carbon, H present, as well as the sixth carbon outside the ring, CH2OH. The H. Now this is alpha, so beta how to write? Shift this OH at upper side. OH, CH2OH. Rest of the structure remain as it is. At the third carbon OH, H. Fourth carbon H and OH. Fifth carbon H downside and CH2HO upper side. This is the carbon number first, this is carbon number 6, carbon number first, second, third, fourth, fifth and sixth. This is alpha D fructose and this is beta D fructose. Alpha and beta D fructose. So now we having a 6 chemical in ring form, alpha and beta glucose, alpha and beta galactose, alpha and beta fructose. Now taken of this chemical, we will construct disaccharide, polysaccharide as well as other saccharide also. But clear cut difference between dextro and levo. any chemical whose solution there were plain polarized light pass, and this chemical bend light towards right direction, means clockwise, which is indicated by polarimeter, so that is dextrorotatory. And left side rotate means anti-clockwise rotate, so given chemical, that is levorotatory. We are learn this ring structure only for dextrorotatory.